Okay, this video is for Algebra 2 and it's going to be going over dividing polynomials, or at least the basics, the introduction. So we've done adding and subtracting polynomials. We have multiplied polynomials. So we can also divide polynomials one by the other. It does depend on what type of polynomial we are dividing by. So probably the easiest scenario is if we have a monomial, if we are dividing by a monomial, then we're just going to divide each term individually. All right, basically every term in our dividend, the thing we are dividing, we're just going to reduce right over our divisor, the monomial. So basically just split this into three separate fractions. All right, so we're going to take 36x to the fifth and just divide that by 6x squared. Then we'll repeat for 72x cubed divided by 6x squared, and then 48x squared divided by 6x squared. All right, and then a reminder here, when we were multiplying polynomials, remember we would multiply the numbers, add the exponents. So kind of similarly, if we need to divide polynomials, we divide the numbers. So the numbers, the coefficients always just do whatever the operation is, but the exponents are one operation behind. So like the coefficients divide, but the exponents subtract. All right, so like here 36 divided by 6 is just 6. But then for x to the fifth over x squared, I subtract because it's like these two x's here are going to cancel out 2 of the ones up here, but there are 5 up here. So if I take 2 away, there are still 3 left. So I get 6x to the third. And then we just repeat that for the next two terms. So 72 divided by 6 is 12, and x cubed divided by x squared. So again, 3 minus 2 is just 1. So x to the 1, and then 48 divided by 6 is 8, and x squared divided by x squared, that's something divided by itself. 2 minus 2 is 0. The x term is going to disappear completely. So our result, our quotient, is just 6x cubed plus 12x plus 8, and that's it for that one. That's all we have to do. So dividing by a monomial is really pretty easy. So you could go ahead and pause the video to try this one on your own and see if you get the right answer. All right, so for the second example, again, we just apply our denominator to each term in the numerator, creating 3 small little division problems, 3 fractions. Divide the numbers, subtract the exponents, and we're going to get this answer right here, 8x cubed minus 3x plus 7. And that is our final answer. So dividing by a monomial really is going to be the easiest scenario. It's pretty simple. And usually if we're dividing by a monomial, these are going to divide evenly. If by chance they didn't, you could just leave the result in fraction form. But for polynomials, typically they're going to divide evenly. So now, if we want to divide by something else, and we could divide by a binomial or even a trinomial, but for our purposes right now, for this video, I'm going to focus on dividing by a binomial with a coefficient of 1. We can use something called synthetic division. Now, there is a long division of polynomials. All right, and you can find lots of videos for that. But if we are dividing by a binomial where the leading coefficient is just 1, like this one, 1x minus 3, synthetic division is actually the easiest way to do it. So what synthetic division does is it's kind of a shortcut for long division of polynomials, which again is a valid way of doing this. There's nothing wrong with it, but synthetic is kind of a nice shortcut. And especially if your goal is really to just get the polynomial solved and you're working with things that mostly have leading coefficient of 1, synthetic is the way to go. So we're going to have 2 parts of this, all right? We're going to take the coefficients of our polynomial, our dividend, the thing being divided, so it usually goes first. We're going to write all those coefficients out in a row. So the leading coefficient is 1, the next one is -2, the next one is 1, and the last one is -12. So we're going to write those out. And then I've drawn this kind of L-shaped bracket here. You don't have to draw this in, but we do want to leave a space right here underneath these coefficients before we write the next row. So typically we'll draw kind of a little L shape here and leave a second row for more numbers. Now the other thing we need, okay, so that's our dividend, the thing we are dividing from. What we are dividing by is x minus 3. Okay, and the way we're going to do this for synthetic division is we're actually just going to find the root or the solution to x minus 3 equals 0. So you're going to take the thing you're dividing, whatever that factor is, x minus 3, and just set it equal to 0 and solve it. So in this case, x minus 3 equals 0, we would just add 3 to both sides and x equals 3. All right, you may notice that that is just the opposite sign of what 3 has in the factor. You can also use that as a shortcut. You're just going to take the opposite of what's in the factor here and put that up here as your root. Okay, so basically now what we need to do is divide all of the coefficients by this root. But this process, this kind of quick little process, gives us a shortcut way to do it. So you'll notice there's an arrow here. The first coefficient, our leading coefficient, we are actually just going to bring that down to the next row. So the leading coefficient there is going to become our leading coefficient here. This is going to be where our answer is, right on this bottom row. Okay, so we brought this down, and we need something here to get us started. So now we're going to go use that 3. And what we're going to do, our process of synthetic, after we've brought this down, we're going to take this number out here, our root, we're going to multiply it by the number down here, in this case 1, and then we're going to write the answer back here above the line in the next empty spot. So 3 times 1 is 3, and I'm just going to put 3 right there. Okay, now what I'm going to do is combine these two terms. I'm just going to add those numbers. So negative 2 plus 3, and you do add them with the signs as they are. Negative 2 plus 3 is positive 1, because it's 3 minus 2. And then repeat the multiplication process. So 3 times 1 is 3 again. Write the answer up here in the next empty spot. And you don't need to put all the extra lines and arrows. I'm just doing that to help show you where they go. So then we're going to add down again. So 1 plus 3 is 4. And then we're going to multiply one more time. You go all the way until the end when you run out. So 3 times 4 is 12. Negative 12 plus 12 is 0. All right. Now this down here is our remainder. Now notice if there's a remainder of 0, that means they divide evenly. So we don't have a remainder, really. The next problem that has a remainder, I'll show you what to do. But so our answer, well, it's not the finished polynomial answer, but we have the coefficients of our answer, 1, 1, and 4. Okay, so all we need to do now is put our variables back in. And so we started with x cubed. We started with a cubic. We divided by a linear factor and x to the 1. So think about if we do x cubed divided by x to the 1 and subtract those exponents, we would get x squared. So pretty much you're just going to go down 1 from your starting degree. So the starting degree was 3. So if I go down, it's going to be 2. And then we're just going to fill our variables in behind these coefficients. And I'm sorry, I'm kind of making a mess here. But so that's going to be 1x squared, which you could put the 1, but we don't really need it, plus 1x, which can just be x, and then plus 4, and I ran out of x's because it's x to the 2, x to the 1. This would be x to the 0, which that's just a constant term. We didn't have a remainder, so there is nothing else to write on this answer, and that is our quotient right there. All right, and that's the process of synthetic division. So obviously we're going to do some more examples. Okay. So the next one, we have a quartic, as in 4th degree, 4, 3, 2, 1, 0. All right, so again, we take the coefficients of that first dividend, the first polynomial, and we write out our coefficients in order. So 3, 10, negative 6, 5, negative 7. I just list those out. No letters, no variables, just the coefficients. All right, then over here for our root, remember we're going to take our factor, but set it equal to 0 and solve it. So if x plus 4 equals 0, x is going to equal negative 4. If you can remember that you also just change the sign, positive 4 turns to negative 4, and there you go. All right, so remember our process. The first thing we do is bring the leading coefficient down because we need something to start us off to do our multiplying and then adding. So we bring down our leading coefficient to 3, and now we're going to multiply. So negative 4 times 3, I've got a negative 12, just put it in the next empty spot. And then 10 plus negative 12, 10 minus 12 is negative 2. And then repeat the process again. Negative 4 times negative 2 is 8. Negative 6 plus 8 is positive 2. Negative 4 times positive 2, negative 8. 5 minus 8 is negative 3. And finally, negative 4 times negative 3 is positive 12. Negative 7 plus 12, 5. And because we have gotten to the end, remember this is our remainder. 5 is the remainder. And so we write the remainder a specific way, but let's get our coefficients into the answer. All right, so we started with a 4th degree. We are decreasing by 1. We took 1 away. So this is going to be cubic. So this is my leading coefficient 3. And so I'm going to put an x cubed behind it. Again, because I'm going down 1 from where I started. So 3x cubed. The next coefficient is negative 2. And work your way down on the exponents. So now is x squared. Okay, my next coefficient is 2. The next exponent would be x to the 1, which we don't have to write. And then minus 3 would be x to the 0, which we don't have to write. So the exponents go 3, 2, 1, 0. Now, what do we do with the remainder? Okay, we have to show that the remainder, it's not just 5, it's 5 still being divided by that, right? If you think about a mixed number, something like 17 divided by 5, and I'm just going to write this over here. Say I did 17 divided by 5, okay? You could write that as a decimal, or you could say, well, 5 goes into 17. It doesn't go evenly, but it goes into 15 3 times, right? 5 times 3 is 15. And so then there's 2 left, but it's 2/5 because I don't get all the way to a full 5. So 5 goes into 17, 3 and 2/5 times. So we're going to use a similar strategy to write this remainder. We have a remainder of 5 that didn't fully divide by, what was our divisor again? What were we dividing by? X plus 4. So we're going to take that x plus 4 and throw it down here under our remainder. Just like over here when we were dividing by 5, the denominator in the mixed number stayed a 5. Same thing here, all right? The denominator in your remainder is just what you were dividing by. And that, as lovely as it is our final answer. All right. So we've got one more example here that I'm going to show you. And notice we've got our big box here that says remember. So this must be important. So what are we going to remember? We are going to remember, okay, to write a 0 in place of any missing terms. We're going to write a 0 in place of any missing terms. And this next example will show us how to do that. So our degree is 3, so it's a cubic. So notice it goes x cubed, and also here I got some space to just draw our own little box. So remember your L. I'm going to put our coefficients in here. Okay, so the leading coefficient is 2x cubed. Next, this is negative 1. And then next would be x squared. I'm sorry, next would be just x. So it goes 3, 2. The next one should be x to the 1. It isn't there. Where the x term should be is right here. There's not one. So we put a 0 in its place where that term was missing. Okay? So if you've got a polynomial with missing terms, that's what you do. You have to put a placeholder, but it's a 0 since it actually is not, there's nothing in that term. And then our last one, negative 25. So 3, 2, 1, we put a placeholder in the 1 exponent and then 0 exponent. So there's the coefficients. Remember, we're going to take our root. X minus 3 equals 0. So we would add 3. So the root we're going to divide by is 3. Put that up here. All right, and then remember, the other important part of this process is the leading coefficient has to come down to the bottom to get us started. So once we bring down our 2, we're ready to multiply. So 3 times 2 is 6. Bring it over, write it here above the line. Negative 1 plus 6 is 5. And then repeat. 3 times 5 is 15. 0 plus 15 is 15. 3 times 15 is 45. And don't be alarmed if you get kind of bigger numbers. That's okay. Shouldn't be in like the hundreds, but you know, double-digit numbers is okay. And then negative 25 plus 45 is just going to be positive 20. And since we've run out of room, that's the remainder. So we'll put that in our fraction form. All right, don't forget we need to put our coefficients in. So we started with a cubic, a degree 3. So that means we go down 1 to x squared. So leading coefficient of 2, x squared, plus 5, x to the 1, plus 15. I don't need an exponent, or I'm sorry, a variable. And then for the remainder, it's 20. So plus 20 over, go back to the beginning. What is it we were dividing by? X minus 3. And there's our quotient. So that is how we do the basics of synthetic division, which is the primary type of division that we're going to focus on right now.